Welcome to Ask and Learn.
The domain for this function is x cannot be 1. That cannot be -1, sorry. The intercepts are 1, 0, and 0, -π/4. There's no symmetry, and for asymptotes, we can look at the limit as x approaches infinity of our function, inverse tangent of x minus 1 over x plus 1, and that's equal to π/4. And we realize that if we do the limit as x approaches negative infinity, it's also π/4. So the asymptote in either direction, so let's write that down. So as x approaches plus or minus infinity, we see that y has an asymptote at π/4. And remember, this is horizontal asymptote. And now we can look at our first derivative to look for increasing and decreasing intervals to see if we have a min or max. So y prime, and here we can just do chain rule u sub. Y prime is 1 over x squared plus 1. Set that equal to 0 to find our critical points. It's inconclusive. So we can't use the first derivative test, but we can look for y double prime, which is -2x over x squared plus 1. That's all squared. Set that equal to 0, and we see that we have x equals 0. All right, so now our second derivative test for concavity. Let's look at 0. Anything smaller than 0 is going to be concave up. Anything bigger is going to be concave down. Remember, we're plugging into our second derivative. So we have our concavity. And now we can graph with the information we have. So we know that x cannot be -1 for the domain. So we're going to keep that in mind. All right, so let's say this is pi, and this is -π. We have an intercept at 1, 0. So let's say it's about here. And at 0, -π/4. So let's say if this is π/2, -π/4, somewhere right here. This is just a rough sketch. Okay, and now we know that we have an asymptote at y equals π/4. So right about here. Horizontal asymptote at y equals π/4. And now we know that it's going to be concave. Oh, this is an inflection point because it's a sign change. So we see it's going to be concave up and then concave down. But first, let's start on this side. So we know that our graph is going to approach -infinity in the x's. As the x approaches -infinity, y is going to go to π/4. So it's going to look like so y is going to go to π/4. This line here, it's going to approach but never touch. And let's see what happens as we get close here. All right, so we know that it's going to never be -1. So let's say this is -1. Let's say right here is -1. So it can come over here, but never touch -1. And I'm assuming it's going to be a little higher because the closer gets, the more negative the x values get, it's going to be closer to the asymptote, and the further away it's going to be a little higher. So it's a little higher. And over here, I know that it's going to be also the same thing, cannot be -1, but it's going to be concave up if it's smaller than 0. So I'm assuming it's like that. And then if it's greater than 0, it's going to be concave down. So it's going to be concave down. So this is our inflection point at 0, -π/4. So it's going to be concave down, hit the axis, keep being concave down, and approach but never touch our asymptote.